Example 2. Find the GCF of 120, 300, and 360. Step 1. Find the prime factorization of each number using a factoring tree. So we'll start with 120, and we'll break that down into prime factorization. 2 goes into 120 60 times, 2 goes into 60 30 times, 2 goes into 30 15 times, and 3 goes into 15 5 times. So at the end of each branch is a prime factor. Let's come to the next value, 300. 2 goes into 300 150 times. 2 goes into 150 75 times. 3 goes into 75 25 times. And 5 goes into 25 5 times. So again, at the end of each branch is a prime factor. And now let's look at 360. 2 goes into 360 180 times. 2 goes into 180 90 times. 2 goes into 90 45 times. 3 goes into 45 15 times. And 3 goes into 15 5 times. So again, at the end of each branch is a prime number. Step 2. Choose each common prime number the least number of times it occurs in any factorization. So let's start with the factor 2. 2 occurs 3 times in the factorization of 120, 2 times in the factorization of 300, and 3 times in the factorization of 360. So the least number of times 2 occurred was twice. So we write down 2 factors of 2. Now let's come to the next factor, 3. 3 occurs 1 time in the factorization of 120, one time in the factorization of 300, and 2 times in the factorization of 360. The least number of times 3 occurred was 1, so we use 1 factor of 3. Now we come to the next factor, 5. 5 occurs 1 time in the factorization of 120, 2 times in the factorization of 300, and 1 time in the factorization of 360, so we use 1 factor of 5. Step 3. Multiply the factors chosen in step 2. So we multiply 2 times 2, which is 4. 4 times 3, which is 12. And 12 times 5, which is 60. So the GCF of 120, 300, and 360 is 60. That means that 60 is the largest or greatest number that can divide evenly into 120, 300, and 360.